This is a short movie to talk about our recent experiments with RDF and the linked data fragment server. So we've been trying a few other bits and pieces after we'd done our data store contract for storing RDF. And we started with some basic experiments using IPFS to store the data. So we created two files of data and we put them on IPFS, one in JSON-LD format and one in turtle format. So if we have a look here, we can see here is a URL and it's pointing to our IPFS server. And this is some DPpedia data in linked data JSON. And here is another file sitting up on IPFS. That's in turtle format. So we plug those straight into the interface in different sizes again, like you can see here. And because the linked data fragment server already supported JSON-LD and turtle, we actually didn't have to do anything else. They just worked. So that was nice and easy. That was just an experiment using really IPFS to hold the file format. So then we wanted to take it a little bit further. So having done these little experiments with different files in IPFS, we wanted to think about how we could use the blockchain and IPFS to verify the data. So we then wrote a new data source file for the linked data fragment server. So we wrote this JSON-LD blockchain verifier data source. So the intention with this was to verify that the file being used from IPFS was a valid file. It hadn't been tampered with in any way. So what we were doing was storing the hashes of the files. So IPFS gives unique hashes to each file, and we were storing those IPFS hashes in a blockchain contract. So here is our contract, very small, very easy, couple of mappings with IPFS hashes and timestamps, and we put the data in and we checked the data. So it's a very simple contract. So basically it actually checks if the hash is in the contract for that particular IPFS file before it draws this interface. So it's a little bit hard for me to show you that it's working, but basically you can see that most of our collections are 20,000, 40,000, 60,000 and 100,000. And for this particular one with the verification, it jumps from 20 to 60 to 100,000 because the 40,000 record file has failed the validation. So I can show you here that you can see we have 20,000, then 40,000 pointing at a particular hash file in IPFS, 60,000, 100,000. So this particular file of 40,000 records, because the hash is not in the contract that's validating the files of data sets that are allowed, are valid for this example, it's not drawing that one. And then the next thing we did is we thought about, what about if we had a Sparkle database? And it's much quicker still to do queries on the Sparkle database than it is to do them on a smart contract, even though we had those million records and it did work, it was slower. But how about if we used a Sparkle database to do the querying, but we validated the results against a blockchain contract? So that's this experiment here, and that's what we did next. So what we basically did is we created an instance of our smart contract holding RDF and put a section of DPpedia data into it. And then we put the same DPpedia data, but then more of it, into the Sparkle database. And then we wrote a new LD server data source, this one, Sparkle blockchain data source. And basically what happens in here is it runs the query as normal against the Sparkle database. And then when it gets the results, it takes all the sections of the triple, or the quad in fact, and hashes them and checks for that combination of hashes in the contract. And if it's in the contract, it marks the result as verified, valid, and if it's not, it marks it as unverified. And then I can show you this in the interface. So basically we're looking at a Sparkle data store with 100,000 records in it, but we've only put some of those records in the smart contract that is being the validator. So once we get a certain way through the paging, they start not being validated. So if we go through a lot of the pages and we get further on through the pages, you can see that we eventually, so this is page 209, I've skipped 2 for you. So here we have 97 unverified results. And if I go to the previous page, there we are, a couple of pages back, you can start to see the difference. So we have 18 verified results and 79 unverified results, and so forth. And that's got 97 verified results. So we can say that from the Sparkle database, 18 results on this page are verified, and these are records that are unverified. So if you had a Sparkle database where people have been adding data that they're not supposed to have, and you were trying to have a validated and static data source for something you were doing, you could use this as a way of checking that none of the data in the Sparkle database had been tampered with, while keeping all the speed of pointing at a Sparkle database instead of a smart contract. So it's just another way we explored in using smart contracts with RDF data. Either you can use it directly as a data store, or you can use it as a source of validation for other sorts of RDF data held in files or held in Sparkle databases and so forth.